When simplifying radicals, we really have sort of two ways of thinking about it. If I take the square root of 75, for example, one way to do it is to look on my perfect square list and then see what's the biggest perfect square that'll divide evenly into the number 75. So perfect squares are just developed by multiplying, like 2 times 2, 3 times 3, 4 times 4. That's how we get the perfect square list. So on this list, the biggest number that'll divide into 75 evenly is 25. So I can put it as 25 times 3. One of the properties of radicals is if you multiply, you can go ahead and split the radical up and make it 25, square root of 25 times the square root of 3. And the reason for doing this perfect square list is because now I know what the square root of 25 is. That's just the number 5. And the square root of 3 is left under the radical. The other way that you could consider doing this is by the pair method, or you're breaking it down using the factor tree. 75 is 25 times 3. 25 is 5 times 5. And you've broke it down to its prime numbers. And then anywhere you have a pair of primes, you circle it, and that's the number that's going to come out. So, for example, square root of 75, then, I have a pair of 5s. The 5 comes out. The 3 at the end of the branch is left over. That's under the radical. Okay. So if I take, maybe a slightly bigger number, like square root of 216, and I want to use the pair method or the factor tree, I can use my calculator to help me out. I see that it's an even number, so I know that at least 2 will divide into it evenly. So I've got 2 times 108. Okay. Well, then 108 breaks down, because I know 108 is divisible by 2 as well, because it's an even number. So if I divide by 2 there, 2 and 54. And I can keep going. 54 is divisible by 2. All right, but now 27 isn't going to break down by 2 times something, because 27 is an odd. So 3 times 9 is 27, and 9 is 3 times 3. So I have it broke down completely by its primes, and now I can go through and circle. And each time I circle, that pair comes out from under the radical. And I have another pair here. So the 3 comes out. And it comes out as multiplication. So it's 2 times 3, not 23. And then what's left over, the 2 and the 3, are going to be put under the radical. And again, it's all multiplication. So 2 times 3. So 2 times 3 is 6. And then square root of 6. I would have gotten the same answer had I used my perfect square list and seen that 36 divides into 216. So square root of 216 is divisible by 36. And when you do that division, you come out 6. So square root of 36 times 6. Square root of 36, square root of 6. And then that first number, square root of 36, is a perfect square, so it's just going to be 6, and then the square root of 6 stays under.